Good afternoon. My name is Michael O'Connor, and I'm the Sales Engineering Director in Oracle's North America Cloud and Infrastructure Solutions team. I'm based in Dallas, Texas, and have been with Oracle since the Sun acquisition in 2010. Today, I'm going to talk about our secure cloud infrastructure, focusing on some of the unique systems and data security capabilities that Oracle provides. The goal of this presentation is to highlight the importance of security to our customers deploying private clouds internally, and to emphasize that strong network security, while certainly still an important part of any defense-in-depth enterprise strategy, is no longer sufficient in combating today's security challenges around protecting corporate intellectual property. Oracle has a comprehensive security strategy and a rich multi-layer security portfolio. We won't attempt to cover the entire portfolio in detail here, as that would take several hours, but we will focus in on some unique differentiators we have at the infrastructure layers, namely with Solaris 11 and the latest SPARC CPUs. I'm sure this isn't the first time you've heard that the cloud changed everything. That's certainly ringing true for the IT hardware market, where we see competitors without a viable public or hybrid cloud strategy struggle to retain relevance. We're also seeing a wide range of traditional businesses, from transportation to lodging to retail, experience tremendous disruption due to cloud. Fortunately, Oracle began rewriting our core software technologies for the cloud nearly 10 years ago. And with our extensive portfolio of SaaS, PaaS, and now infrastructure as a service offerings, we're in a unique position to help customers adopt a private cloud model internally, as well as help with their transition to public or hybrid cloud when that best aligns with their business needs. For our customers, moving to a private cloud model on-premise represents not only a necessity, but also a tremendous opportunity to increase velocity, responsiveness, lower operating costs, and stay competitive. The adoption of cloud technologies like social, mobile, and Internet of Things is leading to dramatic increases in data growth. Along with this explosive growth is the expectation that this data will be available 24/7. What's also growing, not surprisingly in this age of high-profile mega breaches, is the importance of securing both data and infrastructure, which requires increased levels of confidentiality, integrity, and availability. While these factors are certainly also important when considering public cloud providers, the focus of this presentation will be on securing on-premise private cloud deployments. Since not every customer can or even should move 100% of their enterprise workloads to the public cloud today, many customers are moving to some form of private cloud internally. Now, there are clear benefits to implementing private clouds, including increased automation, self-service provisioning, elastic capacity and chargeback, and a generally increased responsiveness to the business. Traditionally, applications have been deployed in silos with a mix of servers and storage, making it difficult to share resources, meet spikes in demand, etc. Managing this mix of vendors and technologies is also an administrative challenge, and this approach can be difficult to secure. The first step in moving to a secure private cloud infrastructure is to consolidate servers and storage to create shared pools of resources that can then be virtualized. This greatly simplifies application provisioning and management. Moving from a consolidated model to a true private cloud requires the introduction of cloud management and orchestration software, but it also means making security a top priority. Now, as you can see from the map, breaches of both private companies and government systems is growing, both in terms of the number of breaches and also in terms of the amount of data being compromised. A recent study by FireEye suggests that 95% of all companies have already been breached, and those companies generally fall into two categories: those that are aware they've been breached and those that haven't yet figured it out. You'll notice a large concentration of breaches in North America, but this doesn't necessarily mean there are less breaches outside this part of the world. Many of the reporting laws we have here in the U.S., for example, have not been mandated globally. One example of this growing trend is the 2011 Sony Entertainment breach of the PlayStation Network, which compromised about 12 million credit cards. The 2014 Sony breach, in contrast, exfiltrated an estimated 200 terabytes of data. No one even knew that it happened until it was publicly disclosed. Causes range across the board, from insider access, password theft, misconfigured systems, and more, and no industry or vertical market is immune. According to the annual Verizon Data Breach Incident Report, we know that 82% of attacks are related to user, system, or database vulnerabilities. Of 63,000 breaches sampled in 2014, we find that 50% of the attacks are user identity related. This means that 50% of the attacks leverage lost, stolen, or weak passwords. It also means that 50% of all hacking can be mitigated with stronger identity management tools and practices. Nearly 20% were caused by poorly configured systems, which basically translates into systems that are not current with their OS level or patching, and most of those exploited vulnerabilities were well known for more than a year before the breach occurred. Finally, 13% of attacks are against a relational database using SQL injection, which is a result of inherently insecure and poorly written C and C++ application code. Oracle offers industry-leading products in each of these security domains. We have identity and access management software that can enable fraud detection and enforce password strength and change requirements. We also have very strong database security for both data at rest and data in motion, which is made even stronger with our recent advancements in CPU technology. We estimate that 65% of the world's data lives in Oracle databases, and with Oracle technology, we can help reduce this attack surface by as much as 80%. To highlight the importance of getting this right, let's take a closer look at a recent event I think we're all familiar with. It's worthwhile taking a closer look at the Sony breach because just as the cloud is changing everything we know about the IT business, so has the Sony breach changed everything when it comes to how we view and evaluate security. The Sony breach literally wreaked havoc on the organization, and here are just a few of the issues that Sony had. First, they had passwords leaked, which were surprisingly stored in a file called password. Next, they had embarrassing emails that discussed the horror of relying on Adam Sandler's mundane and formulaic approach to storytelling, as well as derogatory comments about the president. They even had employee discussions involving personal items, such as trying to get pregnant and prescription drug use, which were leaked. And finally, there were a number of movies that were leaked prior to release. Now, we can debate as to whether the movie The Interview ever should have been made or released in the first place, but the point is that Sony was essentially blackmailed to not release the movie. Theater goers were actually threatened, and this is the first time something like this has ever happened in history, and all because the nature of the data breach involved corporate intellectual property. This second Sony breach has refocused attention on securing intellectual property, the very information that runs an organization. Imagine now if this IP had instead been from a pharmaceutical organization's trial results. They could have lost millions of dollars in revenue, or Coca-Cola's secret recipe, or Exxon's next drilling location, or Apple's 3-year iPhone roadmap. This data breach is representative of the types of attacks of great concern to companies like JPMorgan Chase, who recently announced their plans to double their cybersecurity spend from $250 to $500 million annually. Oracle's goal with our secure cloud infrastructure is to create an information fortress that provides multiple layers of security defense, so that the failure of any one layer does not necessarily mean that data will be stolen or otherwise compromised. To do this, we take advantage of our unique ability to integrate hardware and software to protect both applications and data. There are 3 prescriptive steps that Oracle recommends. The first is to reduce the surface area of the attack through consolidation. It's a simple fact that it's far easier to secure fewer critical database systems than having them scattered across the enterprise running on dozens or even hundreds of different vendor hardware, OS types, versions, and patch levels. Some might argue against putting all your eggs in one basket, but it's actually much more effective and efficient to secure critical databases than is otherwise possible in a sprawling environment. And most data breaches are not due to poor technology, but rather to poor process, and this problem is exacerbated in a complex multi-vendor environment. Furthermore, how can you possibly audit those practices? It only takes one mistake, one door left open for the breach to occur. Next, we need to encrypt the data so that even if or when someone gets through our defenses, the data they capture is scrambled and useless. Oracle delivers the highest set of capabilities commercially available to secure the Oracle database, with Oracle Advanced Security option and the SPARC M7 with on-chip crypto acceleration and silicon-secured memory. With SPARC M7, we are essentially able to offer end-to-end encryption with no impact on performance. The last step is to harden your infrastructure with features built into the Solaris operating environment so that security is fully integrated across both hardware and software. A medieval fortress has many layers of defense, such as large open fields, moats, the drawbridge, and strong high walls. As you can see here, Oracle's approach to information security has a comprehensive and integrated set of layers as well. For this talk, we're going to focus on these middle infrastructure layers, but if you're interested in better understanding some of these others, we can schedule additional follow-on sessions. So we know that 94% of all breached records actually originate from inside the data center, not from lost laptops or tapes falling off the trucks. With this in mind, securing the network perimeter will not reduce the risk of vast amounts of structured and unstructured data lying around most companies. In fact, typically 55% of customer-sensitive production data resides in non-production systems where security is much more lax. And today, nearly 50% of organizations don't even encrypt their sensitive data. As we move through the rest of this presentation, it's useful to classify vulnerabilities into three distinct buckets: people, platform, and data. For each category, there are different risks and different methods of dealing with each. According to the Mandiant Threat Landscape Report, 100% of all attacks target username and password credentials. Why is this? It's because most people are infamous for two things when it comes to passwords: making them too easy to guess and then reusing the same password everywhere. It's especially important to protect the credentials of privileged users that have access to sensitive information. This, of course, includes systems and database administrators. Privileged user controls can go a long way to mitigate these data breaches. By not empowering those credentials with more access than needed, if these accounts are compromised, any resulting breach would be restricted and limited in scope. Solaris 11 has several unique features for limiting the impact of stolen credentials. The first is delegation, which means that users are only granted the right to access certain files or systems and which system parameters they can modify. If a user has their login credentials stolen, if they don't have access to critical data or important systems, then sensitive data is still protected. Time-based access control means that users can be limited to the time and the days they have access to the system. For example, if a user is allowed access to the system only during working hours, they or someone has stolen their credentials can't access the system at another time of day. Lastly, it's really important to make sure that the attacks are discovered and the extent of the attacks logged. With Solaris 11 fine-grained auditing, we're able to determine the who, what, when, where, and maybe even the why the breach occurred. Audit logs are pushed to a secure and remote system so that the hacker can't later destroy them and cover their tracks. We also know that 99.9% of data breaches were against systems that had not been patched for at least a year. Now think about that. Effectively, 100% of the vulnerabilities were compromised within a year after the patches were first made available. Organizations are taking much longer than they should to patch. Taking this a step further, we can see in this chart the total number of CVEs, or common vulnerabilities and exposures, that were exploited in 2014 and when the fixes were originally published. According to the independent Oracle Users Group Enterprise Data Survey, 74% of organizations take more than 4 months to patch their Oracle databases. It doesn't take specialized hardware or software to improve security. It takes better application lifecycle policies and practices. Systems must be patched and updated regularly. But when we talk with customers, it's not uncommon to find that there are quite a few systems, or maybe even more than a few, that are still running Solaris 8 or Solaris 9. Traditionally, the philosophy was to leave the servers alone. They're running just fine, don't mess with them. You may be aware, however, that between March of 2014 and 2015, more than 20 million records were stolen from the U.S. Government Office of Personnel Management. That data stolen was reportedly running on SPARC Solaris servers with Solaris 8 and Solaris 9. In other words, this critical data was hosted on servers with very old operating systems that were no longer secure against modern attacks. A pretty straightforward way to improve security is to update your operating systems and make sure that all security-related patches are applied. At the risk of beating a dead horse, computer systems must be patched routinely to be secure. Too many breaches could have been prevented if systems were up to date. So then why are so many systems remain unpatched? The simple answer is that given the way most IT departments do things today, patching is really, really difficult. Many customers have servers from one vendor, OSs from another, storage from a third, and application software from a variety of vendors. All of these vendors create and publish patches to fix various issues, including security vulnerabilities. Unfortunately, patches created by different vendors are not tested with one another and may in fact conflict, leading to new problems. To avoid these problems, IT managers first need to test patches for one component against the other components in the stack to make sure they don't adversely affect application stability. If a patch is applied and it does cause issues, it can then be very difficult to roll back and remove. This testing and manual rollback process takes time and is a frequent contributing factor to IT managers not updating their software as often as they should. Conversely, Solaris 11 customers have a much easier update process. Oracle patches are tested with other layers of the Oracle stack to avoid conflicts. Customers no longer need to do their own validation of patches and identify possible conflicts with other layers. Oracle Solaris 11 patching has some key advantages such as live patching and one-step rollback, and patches can also be applied while the server is running. The only downtime needed is for reboot, which is typically just 1 or 2 minutes. If there are problems after reboot, a one-step rollback makes it easy to remove the patch and return the system to its original state. This new package delivery system, first introduced with Solaris 11, is the enabling technology for this enhanced patching capability. By making it easier and faster to patch and upgrade systems, Solaris 11 greatly enhances security. Our customers have told us that Oracle Solaris is significantly easier to patch and update. One large financial customer, for example, told us in their environment, one administrator can manage and patch about 250 red-hot systems effectively. But with Solaris 11, that same administrator can manage and patch nearly 4,000 systems. Now let's talk a little bit about compliance. Compliance is something that everyone is dealing with today, and in some industries, compliance management and auditing accounts for up to 60% of the total IT spend. Solaris has a powerful and simple-to-use compliance tool based on open standards. However, it's the only platform in the world with a built-in PCI DSS compliance benchmark. One simple command, compliance, provides a full report of your system and easily identifies compliance issues. Solaris goes even further. By simply clicking on a failed test, we provide the script needed to remediate the problem. One of our customers is a large online retailer. Before the Solaris compliance tool, their audits would take weeks, and auditors would want to log into each of the systems and view how things were configured. After rolling out the Solaris compliance tool, the director of IT simply handed the auditors thousands of pages of report generated by the tool. The auditors took the reports, spent 2 or 3 days reviewing them, and left certifying the customer as PCI compliant. Now, the average cost per user record stolen in a data breach is estimated to be $194. In this era of mega breaches we've discussed, a single breach can now add up to hundreds of millions of dollars, so it's absolutely critical that data be protected. The database and the infrastructure on which it's deployed is the final and best defense in protecting critical information. All layers of security, including perimeter, network, endpoint, etc., play their role, and the more layers of defense, the better. But an enterprise's most critical information resides in its databases, and so it's critical that those be secured. The impact of the data center breach can be minimized if the data the bad guys are looking for is properly protected. And fortunately, information security technology and processes are actually the most mature in the database area. As we can see in this chart, IT leaders identify database and network as their most critical security areas. That said, surveys show that IT organizations generally overinvest in areas that don't directly protect their databases, leaving databases relatively unprotected. This investment pattern is misaligned with the true nature of the threat. As you can see, 2/3 of all security spending is focused on the network, which is really important, but even more important is data security, and the spending there lags far behind network. So why must spending increase on data security? Because the data shows that only 24% of attacks were actually stopped by network security. When burglars break into a home, they look for electronics, jewelry, or cash. Yet homeowners focus mostly on securing their doors and windows, not their valuables inside the house. This mindset permeates businesses as well, assuming that at some point someone will break into your network. When they do, you don't want all the good stuff simply lying around on the kitchen table. As we showed on the last slide, it's not enough to protect the network and try to keep hackers from gaining access to your data. You also have to protect the data. Oracle's SPARC M7 processor has 15 encryption cipher accelerators built into the processor. They can encrypt databases, applications, and transactions between layers without adversely affecting application performance. This completely negates the need for any external encryption cards or devices. There's no need for specialized high-overhead encryption software. And with the SPARC M7 built-in encryption, we can protect both data at rest and data in motion. Oracle VM Server for SPARC, or LDOMS, uses the SPARC M7 ciphers for secure live migration, which encrypts virtual machines when they migrate over the network from one server to the next. The Oracle Database Security feature, TDE, or Transparent Data Encryption, takes advantage of the SPARC M7 ciphers to encrypt and protect all of your data that resides in Oracle databases. A common security flaw, especially in applications written in C and C++, is unprotected memory and buffer overflows. Heartbleed and Venom were two of the more notorious attacks that exploited this common weakness. C and C++ don't automatically prevent buffer overflows or the reading or writing of memory beyond what was originally intended and allocated. This lack of memory protection can be exploited by hackers to directly access data and memory and compromise an application by inserting malicious code. Good programming practices can prevent this, but good code is hard to write, and there are thousands of applications and millions of lines of code that are vulnerable. What's needed then is a way to fix this without having to rewrite the application. Oracle is addressing this in our new SPARC M7 CPU with a feature called Silicon Secure Memory, or SSM. And it's the first ever hardware-enabled memory protection technology and a unique differentiator for Oracle systems and end-to-end security. SSM provides real-time data integrity checking to guard against memory pointer-related software errors and malware. If an application tries to accidentally or maliciously access memory it shouldn't, the application is shut down. SSM can be always on with minimal performance impact, which is a significant advantage over software protection methods. By having SSM integrated at the processor level, this provides significant developer efficiency and much more secure applications. Very briefly, here's a description of how Silicon Secure Memory works. SSM detects and reports memory reference errors and stops unintentional or malicious access to data and memory. SSM in the SPARC M7 processor combats buffer overruns by using the unused upper 4 bits of each memory pointer to serve as the memory version or color. During the process of memory allocation, this 4-bit pattern is written into the memory pointer. When this memory is accessed by any pointer, the 4-bit patterns are compared. If the patterns match, then the access is legal and allowed to continue. If the patterns don't match, the program terminates. SSM can be on all the time with near zero performance overhead. So why is Oracle the best organization to partner with in the area of data security? 3 reasons. First, we mitigate credential abuse and misuse with unique capabilities that make it difficult to exploit user credentials. We have advanced patching that's simple and secure, so customers can stay up to date with the latest releases. Finally, we have end-to-end, always-on cryptography and memory protection, so you no longer have to compromise between performance and security. So I'd like to leave you with this last quotation here from Yafim Nadas of Gartner. Some vendors know enterprise, some vendors know cloud. Only those that can master both will be leaders. Thanks for listening.